In His time, He makes all things bright and beautiful. My God is never late, He always on time. Your God will never fail, He will surely come. Just keep on holding on, for the Lord your God will never let you down. Lift you up. He walk it, what's not you think? I won't
This is our video number 2 on the lesson of variation. Now in our previous video we looked at the first part of variation, which is direct variation, inverse variation, and then joint. Okay, so the hybrid format of the two, which is the joint variation. So we treated that and we saw that in variation, when we are given an item, it's just showing expressing the relationship between two items, maybe how they are related. Okay, so let's say V and then I are directly related, V and R are inversely related, those kind of things. So when they say direct relationship, it means that when you increase the left one, the right one will also go up. By inverse relationship will be when you increase the left one, then the right one is what? Going down. Okay, so that is inverse. It's inverse. It's inverse. Okay, so very well. This video we are going to be looking at what we call partial variation. Partial variation. Now, this particular aspect, what it means is that this one does not have a full influence. Does not have a full influence on the items that we are comparing. Okay, so it means that a part of it is true, but a part of it is not true. Okay, so we can say it's really not the case. Okay, it's really not the case. So let's say we can say, okay, children inability to, or students inability to like mathematics is because the course is what? Difficult. That is a partial variation, okay, or a partial establishment. What I mean by that is, it could be a factor, but it's not entirely a factor. Are you okay? So with this one, there is a bit of it that is true and a bit of it that is constant. Okay, so a bit of it doesn't change, and then a bit of it is there. So it's like saying that, okay, if we make mathematics less difficult, would the students like it? The answer is actually no, because there will be a certain part of it which will also make them being scared. Okay, so it is such assertions that we say are some forms of what? Partial variations. Okay, so in partial variation you have a part of it being constant. No matter what you do, it will change. And then a part that can what? Vary when you change certain what? Factors. Okay. So partial variation. Partial variation. Partial variation. Okay. So with this one, anytime you hear a question like the cost of an item is partly constant and partly varies. So they will say a part of it is constant and a part of it varies. Okay. Whenever you hear partly, then know you are under partial variation. So you know in the joint and in the direct and the inverse, there is nothing like part. It's a total, a holistic word assertion. So this particular one, part of it is true, part of it is not. Okay. So let's say we say the cost of an item is partly constant and partly varies as what? The quantity. So the cost of an item is partly constant and then partly varies as what? The square of maybe the quantity you are buying. So then this one, the cost is partly constant, so The first constant is called K1, and then the second constant is what? K2. So the cost of an item is partly constant, and so the end there is a plus, and in partial variation here is always a plus. Okay, so the cost is partly constant and partly varies. So when you know that when you hear varies, it means you are supposed to use the variation symbol. And the variation symbol, like I said, it doesn't mean anything in math. So you must replace that variation symbol with a constant. And so that's what will introduce the second constant of what? Proportionality. So this one, C, is partly constant. You see, so this one will not change. The value is there. And partly varies as what? The quantity. So partly varies as the quantity. So that varies there is what we replaced by what? The second constant of proportionality. So it means that this C value, when I'm changing Q, it will be changing alright. But it doesn't mean that when I set Q to 0, the C is also going to go to 0. No. I mean, if I remove the quantity at all, the cost is still high. Okay? The cost is still high. Are you seeing it? So this type of variation is always partly constant and then partly varies. The same way I can say what the cost of, let me change cost, maybe the quantity of an item varies, is partly constant and partly varies as the months. Number of years it has stayed in the store or whatever. But the whole idea is the partly constant and partly varies is what we are after. So every partial variation is in this format. So let's say Q is partly constant and partly varies as the square of V. That is it. So Q is partly constant and partly varies as the square of V. You can hear, let's say Y is partly constant and partly varies as the what? Cubic root of X. So it can be cubic root of what? X. So all of them is always like this: K1, K2, then whatever variation is mentioned. K1, K2, whatever variation is mentioned. So that's our partial variations. Okay. So in partial variation, this time around, the constant of proportionality we are after here is 2. Okay, it's 2. K1 and K2. So when it's 2, you know that you are going to generate an equation where you have 2 unknowns. And when you have equation with 2 unknowns, unless you get 2 equations before you can solve that. Okay. So this one, unlike the joint and then the direct, that they will give you, when C is 5, Q is 3. Then you can actually use that to find your constant direct and go. This time around, they must give you 2 conditions. When C is 5, Q is 3. And also, when C is 7, Q is this. So you must get 2 conditions before you can solve it. And it will always be provided to you in the question. Okay. So in variation, it's just a matter of identifying what type of question is this. Is it joint? Is it inverse? Is it direct, or is it partial? And I said partial, you hear the word partly. That's why it's called partial. So part of it is true, part of it is not true. Okay. So that is what it's going to mean. So let's maintain this. Okay. Let's maintain this. So we can have the cost of an item is partly constant and partly varying directly as what? The quantity. It can also be partly constant and partly varies inversely as the quantity. So that case, this will be over Q. The same thing. Okay. So they will tell you C is 8 when C is 8 when Q is say 2. Okay. So C is 8 when Q is 2. And then let's say C is let's say 12 when Q is say 3. Right. So C is 8 when Q is 2. And then C is 12 when Q is 3. Are you okay? Yeah, so we have this, okay? So the cost is 8 when the quantity is 2, and then the cost is C is 12 when Q is 3, okay? So now they've given me two conditions. All they are trying to let you generate is what? Two equations. Because I told you need two equations with two unknowns in order for you to get the right answers, okay? So we just first of all put the very first preamble into the top equation. So that's going to be where you find C, you put 8. So 8 is equal to K1 plus Q is 2. So 2K2, and that is going to be what? Equation 1. And then the second preamble, which is C is 12, Q is 3. Put it inside. So then this is going to be 12 is equal to K1 plus what? 3K2. And that is going to be what? Equation 2. So now you see you have two equations with two unknowns. So this is solvable now using the normal simultaneous equation method. We know. And these are linear equations. There are no combination of K1, K2 or either square of maybe the K is over there, right? So we can actually easily detect this or determine this, right? So here, let me rewrite it well so that you can see the normal orientation of equations. So let me do it this way. It's equal to 8 and then this is equal to 12. Then you can see it well. Okay, so then when I have this, I can decide that you see this one, the coefficient and this are the same. So always for partial, K1 will be the same. So always you subtract. Okay, always. I'm not saying sometimes, it's always you subtract. Okay, so you get here, you subtract. So K1, that will be 0. So K1 will be 1. And then you have minus 2K2 minus 3K2. That's going to be minus what? K2. Okay, minus K2, which is equal to. Then you have 8 minus 12. That will be minus what? 4. 8 minus 12 will be what? Minus 4. So at the end of the day, divided by minus 1 by minus 1. So our K2 is going to be what? 4. Right. So easy, we were able to get our first constant of proportionality. If we know K2, we can easily determine K1. Just put it in any of the equations that you have there, you can determine K1. So now we know K2, let's go on determining K1. So let's put it into equation 1. So that this one will be K1 plus 2 times K2, which is 4, is equal to 8. Okay, it's equal to 8. So then you are going to have this equation here. Wow, to be K1 is equal to K1 times 3, and then that is going to be plus 8 is equal to 8. So K1 will be what? 0. Okay, then that is the situation. In ideal cases, this one doesn't really happen, okay, where you have K1 to be 0. The values they are going to give you, of course, will determine you get both what? K2 and then what? K1 values, okay, for your answers. But if you want to maintain what we have here, after you determining K1 and then K2, you just put it in the variation what? Question. You just put it in it, okay? Put it inside here. And so my K1 is 0, so my cost is equal to 0. That is my K1. Then plus my K2, which is 2. So it's 4. So it's going to be 4 times what? The cube. So in other words, my variation equation is equal to what? 4Q. As simple as this. Okay. But like I said, normally sometimes K1 will have a value. Okay, K1 will have a value. So that value will be here. If we decide to maintain what we have here, and maybe do this one, say Q squared. Right. So we do what we have here, Q squared with the same values. Okay, Q squared with the same values. That is, the cost of an item is partly constant, and then partly varies directly as the square of the Q. It's partly constant and varies directly as the square of Q. When you have that situation, and then maybe you have all these ones, then you could have the solution changed into just the same idea. Insert what you have here. So cost is 8. So 8 is equal to K1 is there, then plus my Q is 2. So when you do that, it's going to give me what? 4K2. Okay, 4K2. That's a square format. Okay, and then here it's also going to be putting the second one in there. It's going to be 12 is equal to K1 plus square of the 3 is going to be 9K2. Okay, 9K2. So that's going to be what? 9K2. Right. Then when you have this situation, like I told you, you always subtract. So you can decide to subtract this from that. So you have 8 minus 12, which is what? Minus 4. So 8 minus 12 will be what? Minus 4. And then you have K1 boom. And then minus 4K2 minus 9K2 is going to be minus 5K2. So you have this minus 5K2. So under this condition, when we divide through by minus 5, our K2 is going to be what? 4 over 5. Okay? So our constant K2 is given as 4 over 5. So if we know our K2 to be 4 over 5, then all we need to do is to put it in any of the equations. So to determine your K1. Any of the equations to determine your K1. So that this here will be 4 over 5. Okay, so our K1 is going to be 4 over 5. K2 is 4 over 5. So we just put it in there. Then we have this to be K1 plus simplifying is 8 over 5 is equal to what? 8. Okay, 8 over 5 is equal to 8. So that's a matter of making K1 this. So K1 is equal to 8 minus what? 8 over 5. And therefore my K1 is going to be, well, I can change this one, just use your calculator on this, or you can just use 40 over 5 minus 8 over 5. Okay, 40 over 5 minus 8 over 5 when you do this. Then, since the denominators are the same, you can say K1 is equal to 40 minus 8, and that is 32 over 5. So this is going to be the answer for your K1. So you see, in this type of question, you have both answers, K1 and K2. Okay, so just like the previous example we did, after getting your constant 1 and then constant 2, you only come back here and then you place it in the main variation equation. Okay, the main variation equation, which is C is equal to, let me write that here under it. Okay, so this one is going to be C is equal to my K1, which is 32 over 5, plus my K2, which is 4 over 5, Q squared. So this is going to be your final variation equation. Putting all the constants of proportionalities in there. This is what you are going to have. And so they can ask you to determine the cost if Q is this. So just put the value of Q inside and then punch that on your calculator. You get the answer. Are you okay? You get the answer. So it is a very simple part of what? variation. So in partial variation, all we are looking out for to conclude is what? The two constants of what? Proportionalities. And we said that comes out when you have two different scenarios given to you. So you will be given in any given question, they will give you the two situations. When C is this, Q is this, and when C is this, Q is that. So those two equations, those two situations are going to help you generate what? The two equations in there. So if you know the two equations, just put them. Get equation 1, get equation 2, subtract, and then you come out with what? Your K1 using the simultaneous equation approach. Okay. So that is about it with variation. Okay, that's about it with variation. Remember, you must look out for the word partly constant, partly something. Okay, before you conclude that it's a partial variation. And you must look out for directly proportional. Then you conclude it's a direct variation. And then you can also look out for inversely proportional. Then you can conclude it's an inverse variation. Then when you hear directly proportional to this and maybe inversely proportional to this, those two, they have two different variations in a single question. Then you know that that is what? A joint variation. And in either ways, they will give you the first preamble for you to be able to determine your constant of proportionality. In the case of partial variation, we have two constants. So they will give you two situations. You get two equations. Use simultaneous equation to solve them. Okay, to get your two constants. In the case of joint, direct, and then inverse, you only need one constant of proportionality. So they will give you only one situation. You put it in your variation equation, and then you get your constant of proportionality. After all, any of the quantities within the equation actually is just a matter of algebraic expression, and then change of subjects. Okay. So we've come to the end of a very interesting lesson on variation. So before I yes, contact us if you have a challenge, and then we'll be ready to assist. So until we meet again in our next lesson, that one is watch out for that video. This video and any other video you see us teach on this channel or on this platform is brought to you by kind courtesy Honorable David Tewakeme, the principal proprietor of King David College. He made this video, sponsored this for the good of all, especially those who are having challenges in understanding the basic concepts in mathematics, those who are really struggling, especially the students of King David College, so that you shall go on in your future endeavors as you tackle very, very, very interesting topics in mathematics. So anytime you go on your knees to say any word of prayer, please remember him in your prayers, because he has everybody at heart.
In his time, he makes all things bright and beautiful. My God is never late, He always on time. Your God will never fail, He will surely come. Just keep on holding on, for the Lord your God will never let you down. Lift you up, He walk it, what's that you think? I won't